So I just finished my first year of environmental studies major at this university, and I worked in the poly lab for the summer under the guidance of Aaron Dillon in the ecology, evolution, and marine biology department. So coral reefs in the Caribbean they contribute a lot. In terms of the business and tourism they pull into the Caribbean, they're worth about $4 billion or possibly even more. However, they're very temperamental, and there's a constant competition with coral reefs and algae. Algae are always trying to take space and nutrients away from coral reefs, and if it reaches a state where it's out of hand, algae will start to block coral reefs from reaching any sunlight, causing them to die even more. And that ends up looking at the reef on the right. The solution to regulating this competition and problem is the parrotfish. Parrotfish are large herbivores found in coral reefs, and they consume the algae, keeping algae populations in check, allowing corals to stay alive. So, in order to keep coral reefs alive, we obviously would want to understand parrotfish populations. However, we may not have a proper target to aim for because over the course of humans living in the Caribbean, parrotfish have been eaten and consumed as they're quite large and tasty. So, the goal of our project is to really try to figure out how parrotfish populations have changed over time. If you look at this image, this is what was considered like trophy catch in the 1950 in the Caribbean, and this is what it looked like in 1980. It's a good bit smaller, and this is what it looked like in 2008. It's pretty small. So the conception of what a large parrotfish is constantly changes over time. So taking a survey and just saying like, oh, I see this many parrotfish and they're this large, that doesn't give a full picture of what the ecosystem is capable of holding because things have changed so much over generations. So the solution, which is what my project will explore, is to use parrotfish teeth to try to look into the past and see what parrotfish populations both look like in terms of the size of a parrotfish and the relative abundance of a parrotfish in a coral reef. This is predicated on the belief that larger teeth correlate with larger fish and more abundant teeth correlate with more abundant fish in the system. So the questions that we want to answer are, how did the size and relative abundance of parrotfish teeth differ over the last 6,000 to 8,000 years in the Caribbean, as comparing that time period to now is a good comparison of before human activity and after human activity, and between select sites in the Caribbean and Pacific. Creating this spatial comparison for the second question will allow us to give more context to a temporal change in a single location. So, because we wanted to compare past and present Caribbean reefs, we went to the Dominican Republic, which is over in the Caribbean. And fossils were collected from both sediment samples were collected from both fossil and modern reefs. If you look at the red circle, that represents fossil reefs, and it's actually an above-water reef that dried up several thousand years ago and represents the mid-Holocene epoch, which is 6,000 to 8,000 years ago. This is before the time where humans settled in the Dominican Republic, so it gives a pretty good view of what coral reefs looked like at this time. And then the modern reefs are actually living coral reefs that are underwater, so there was a diving trip that was performed to go collect sediment from there. In order to give a spatial comparison, we also took samples from Palmyra Atoll, which is located over in the Pacific. So Palmyra Atoll is a very similar environment, or as similar of an environment as we could get to the reef found in the Dominican Republic in terms of ecosystem, geography, and wave energy. So that isolates a lot of variables for us to compare just the spatial location, as well as the fact that Palmyra Atoll is a very small island and nobody lives there and there's no fishing activity, whereas in the Dominican Republic there's a very large fishing industry. So with all other variables as similar as we could get, that could tell us whether there's any differences based on fishing activity in the Dominican Republic that is not present in Palmyra Atoll. So after samples were collected, we have all these bags of sediment. But obviously these bags are not 100% fish teeth. There's probably a lot of other things, such as rocks, sand, silt, clay, shell bits and pieces from other animals, corals. So we want to try to get rid of most of them so we can have the teeth left behind. To that end, we dissolve them in acetic acid or vinegar, which dissolves most of the debris found in those sediment samples, as acetic acid and calcium carbonate react to dissolve calcium carbonate. This is kind of in the way that if you were to put an eggshell in table vinegar, it would dissolve, but if you dip your fingernail in vinegar, it wouldn't melt off. So that way it leaves behind teeth, which is what we look for in this study. So over the course of the summer, 825 teeth were extracted and measured, and we used a reference collection collected by the University of California, San Diego, to identify which types of teeth belong to parrotfish and which types of teeth belong to other fish, such as other types of herbivores, carnivorous fish, or fish that consume plankton. So the most common morphotypes of parrotfish teeth were the ones that we measured, and those are the ones that are in circles. The way we measured them was we took the longest and widest measurements on a single tooth and then recorded that. And that's what we used in following analyses. Although before we move forward, I do want to point out that in the modern Dominican Republic samples, as we took samples in both modern Dominican Republic, fossil Dominican Republic, and modern Palmyra, there were these very odd teeth that were very large, opaque, and yellow, whereas most teeth are a lot smaller, translucent, and white. And I put them side by side for comparison. As of now, we don't fully understand why these teeth are present, but it's definitely something we want to investigate moving forward. So the first test that we ran was a test of comparing relative abundance, so the proportion of parrotfish teeth out of all teeth across all sites. Because we had 4 samples for Palmyra, which are two repeated samples across 2 locations within Palmyra, that's why there's 4 bars there. So you can kind of tell if blue represents parrotfish teeth, the Palmyra sites have a much bigger chunk of blue than the Dominican Republic sites, right? So we ended up running a chi-square analysis test, and as it turns out, Palmyra samples actually do have a greater relative abundance than Dominican Republic. And it's possible that this is because of the lack of fishing activity. Dominican Republic has had several thousand years of fishing going on there, while Palmyra has had very little fishing activity, if at all. So that might be an explanation as to why the parrotfish teeth relative abundance is greater there. The next test we ran is a test comparing parrotfish tooth length in the modern Dominican Republic reef and the modern Palmyra reefs. However, if you look at the box plot, the bolded line is the median, and the box itself represents the 25th percentile to the 75th percentile. You could probably see that there's not very much difference. And we tested it, and it turns out that there is not a significant difference. So this is contrary to what we expected. We expected that there would be, that teeth from Palmyra would be larger than teeth from the Dominican Republic, because Palmyra has no fishing activity, whereas the Dominican Republic has a lot. But we were incorrect there. And the last test that we ran was comparing the teeth found in the fossil Dominican Republic with the teeth found in the modern Dominican Republic reefs. And if you look at the boxes here, they're pretty different, right? As it turns out, statistics show that they are different. So, however, it wasn't different in the way that we expected. What I guessed was going to happen was that teeth found from the modern reefs would be smaller than teeth found in the fossil reefs, as when you fish, or when you consume something and exploit a resource, it tends to become less abundant and smaller. However, the box actually shows that it was larger in the modern reefs, and that's likely due to the presence of those large yellow teeth. So moving forward, we would need to investigate why those are present.